welcome to the AI Academy from Imantix. This is Asif. Today we'll be continuing the series on AI fundamentals. Today we'll speak a bit on the different types of AI, what's traditionally been data science and machine learning, and the application of AI, which is popularly called Gen AI, generative AI. So in the different types of AI, it has traditionally it would be called machine learning and data science. And there was this in artificial intelligence, there's been one form or one system which has existed a little bit prior to machine learning, and that's rule-based systems. So we started off with rule-based systems. A rule-based system is a bunch of conditions. If so and so happens, then do this. If this, then do that. I mean, among the first rule-based chatbots that were available, people might not have seen it. It was called Eliza. It was a very early chatbot. It was designed to be a therapist. So in general, therapy is when you talk to a therapist and he just repeats your words back to you. It doesn't add anything to it, and that's what Eliza would do. Eliza was an application which was built, which would just take your statements and make some small changes to those statements and return it back to you. And it was pretty fun. People played with it a lot in initial days. I think it's still available online. Now, as time progressed and people realized, of course, this form of AI is not it's not scalable. You can't create infinite series of conditions for every possible case that exists in the world. So we had a system created called machine learning. Now, what is machine learning? Machine learning is basically you are training a system on data. So you train it on data, and it recognizes patterns. It recognizes the way it should operate. The way it should take decisions based on the data sets that have been provided to it. So machine learning in general was of three types. You have supervised learning, which is basically you're training a system on supervised data, that is labeled data. So what is labeled data? Labeled data is a bunch of data sets where you give the machine a question or a problem statement, and you give it the correct answer. You say that when you encounter this, these were the options, but this was the correct answer. That's called labeling. So it has access to large amounts of data, and you would have labeled data to give it the guide that what is correct and what is not correct, and it would learn on the basis of that labeling. This was called supervised training. Then you have unsupervised training. So unsupervised training, the objective would be to find patterns. So you have unsupervised training. Again, you are operating on a large amount of data, and what you're trying to do is you're trying to detect patterns. So that's what the machine is being trained upon, to detect patterns in the data set. Say, for example, is looking for anomalies. It's looking at banking transactions. It's trying to find out something which is doesn't look correct. And that was the second form of machine learning that is being currently looked at. And then finally, you have reinforcement based learning. So in reinforcement based learning, you give the machine explores. It's a trial and error system. It will try a response, and then there would be some form of reinforcement either from a human being or an existing labeled data system, which will tell the machine whether the decision it took was right or wrong. So it's a reward based system where you give rewards based on selecting the right answer, and that data set, it gets trained on that data set. So this in general was the traditional machine learning system, which is still taught in our colleges, and we still have expertise in that being developed. Then you have data science, which is critical because all of these platforms, they require data, and they need data in a in good patterns for it to work accurately. So data science and machine learning, this was the AI platforms or AI systems that we traditionally were using. Now what changed is you had a form of AI called generative AI, short for Gen AI. Now, generative AI is basically a set of models. It's like your when you're training data, you're creating models out of it. So you took a transformer or a brain or an AI engine. You started feeding with the data using one of the techniques, either supervised, unsupervised, reinforcement-based learning, and you created a model out of it, which can take certain decisions. It can do certain things. Say, for example, it can look at X-rays and tell you whether there's a particular ailment in a particular X-ray or not. This was the kind of AI that was developed. Generative AI was something that really gained popularity six years ago. When and this form of AI, the goal is that you train a model, you give it some prompt, you give it some input, and based on that input, this model will respond to you with certain responses on its training data, where it can generate new content. That's the entire strength, or the concept behind it, that rather than just responding or just telling you whether a thing is good or bad, right or wrong, it can generate entire content based on an input prompt. So this is something that it is an application of AI. It is We have these models, Gen AI models available today, and these Gen AI models are trained on a really large amount of data. They're also called foundation models, and the kind of data that they're trained on, it would go into terabytes and even petabytes today. You need really large systems to run them. They come in a huge number of varieties. You would get very simple Gen AI models that can run with something like, say, 200 million parameters. But then the really large one would be in billions of or even trillions of parameters that they would look at. So what they would do is they take an input from the user, they analyze it on various parameters based on their training data set, and the number of parameters would define the kind of accuracy or the kind of responses that you would get from this particular model. These models have certain restrictions and they have certain limitations. And then what has happened is, as technology has developed, we have found ways to overcome those limitations and restrictions. And as we go ahead in the future sessions, we will discuss what kind of limitations and restrictions are present on these models, and how we are managing to overcome them in these days. Okay, thank you.